Hello everyone, I am Xiao Gang. Let's continue looking at this. First, this has an index of by key. Looking at it, it's actually very similar to the functional code above, but one difference is that it can directly pass this type of key without needing to convert it into an element type through find. What does this sentence mean? So let's implement these two first. Let me explain what it means in more detail. Okay, let's use find element here. Then we'll use find element by key here. Okay, then let's implement it here. And the location of this part seems incorrect. We should be at the very bottom position. Then we'll still use how to 第一天字 he hello. And when using this side, it's actually the same. Let's see if we can find this hello. And then return this index. Obviously, this index equals 0, right? Let's write this one up as well. This is actually passing a match at a specific location like this. It's actually passing a lambda like this too. So what this means is, let's call this index P. But if it includes R, this should return a 2. We can write the expected result here. It should be equal to 0. It should be equal to 1. Yes, the returned index is 1, but it is the second element. Okay, let's execute it. We can click to look at the comments. This is finding an object. And it's through this kind of case. Then it must overload this kind of operator, etc. Only then can it be overloaded. We should be able to use it here. This string, it has already overloaded it for us. Is this usually passed such a large amount? It is found by making this kind of judgment. Okay, we launched it. Okay, let's modify the method we are calling here. Actually, we should be able to grab another one. Maybe we should use a different method next time. It's a little troublesome to cut adjust this part. We can use a different approach, so we don't have to keep changing this blueprint. This should be find element array by key. It's this one. Okay, let's do a dry run and take a look. Okay, there are no problems here. Okay, this should be 0 and this should be 1. No problem. Let's see how we should do it if it is a struct. Okay, let's define a structure here. Let's stick with a struct. This is already a lot. Okay, same thing, a struct. Let's give it a... How about giving it an ID and money? And what we are overloading here is the integer operator. And what we are passing is... The first one is this type. Yes, the first one passed is this type. And the second one should be just int3 and we give it an ID. Then we delete this type from before. We need to change the name. It should be this place. We use then structingful. Alright, this spot of ours. Change the corresponding construction and mechanism. Then here, we use this ID. Check whether this passed ID is less than to perform the check. Okay, we can already compile this on our end. Okay, the structure will look something like this. We are primarily going to overload this operator so that it can directly call this regarding the incoming integer ID. Then let's write it here later. Then we might also need to pass a structure. For the objects inside the structure, we can probably write it like this. Can we write it like this? Let's look at ID 1. Okay, Manis. 2. Writing it this way isn't very reasonable. Okay, let's write it this way. Like this. We write it this way. Add. Writing it this way is fine. Actually, our 1 and 2 are. Then let's look at the error here, right? We cannot give story. We give story struct tree touch those. Okay, this way there is no problem. Then we give ID 2 is 30. We assign an ID of 50 to number 4. Okay, and then here we will execute this instruct. So the object we are passing here is this one. We are determining it. We don't compare it to this. We want to compare it to this. So it should be done like this. Let's take a look. We don't need to pass this here. We just pass an int4 like this. Let's see if it can find this object. Okay, for the object with ID equal to 4. Please pay attention here. We just accidentally deleted the large component below. Let's launch it now. There's a mistake in this deformation package. Let's see what the cause is. It seems that the way this is written isn't quite right. Let's take a look at how to modify it. Okay, let's correct this code. Please note, we just mixed up the strainer and the struct. So, there's a problem. And then, at this spot, we actually need to overload the operator here. Because, as you know, you click in, you'll find that it's actually like this. This is a method within a template. And over here, there's a k. This k is the value that you pass in. It must perform an equality check against your element. And remember, this double equal sign, you have to write it like this. It has to be written in this format to be recognized, right? So this thing, if you write this thing, we will still place this. After you write this, it can compare with this 12. Actually, in this area, we have it compare with 2. We should give it this element. This place should be something. It should be findable. Okay. Then let's execute it again. Now, actually the idea here is you need to drag this operator again. This operator actually has many ways of writing it. You can write it inside. You can write it both inside and outside. As for exactly how to write it, you can actually do it like this. You can take a look at C++. In fact, within our engine, it frequently overloads these methods. Look at its structure, some general structures of it. It performs some overloads like this. It is just to achieve compatibility with our container, to ensure compatibility. Okay, so here we know we do this to it by overloading this operator. Only then can it make a determination. Then we execute it again. You click in to see. This is very interesting. This is a kind of syntax for the prototype. It has 2 prototypes. The first one is element. The second one is k-type. Element is your element type. Then this type is the type you want to compare it with. And it doesn't need to be converted into an element this way. It can directly perform a comparison on this keyword. Then we activate it directly here. Okay, then we zoom in like this. You will notice that this spot is force. If we use force, it proves that this element, it doesn't seem to have recognized that it was found. Let's take a look at this one below. This one doesn't seem to have found it either. Let's check if what you wrote has a problem. The place definitely has a problem with how it's written, because we inherited it. We used the ternary operator. So this spot has a minor issue. We just change it to if, else, or something like that, and it will be fine. Directly return here. Minor issue. Oh, this place is mainly C++. At this point, we should be able to correctly determine whether it is the same. We launch it, then you will find that this should be. Let's zoom in a little. Our A is fine. and then we should be able to find it. This should be index 2. Okay. So we prove that this part of ours, if fully verified for everyone, is usable. Please note this location. We need to reload this component type, and this is a very important method. This returns a pointer. Then actually, if you don't use this O2, it is a very interesting pointer. It's EF character with a star on it. That means it has 2 stars. This type should be called. It's a pointer to a pointer. Yes, that should be the meaning. We can try doing a simple one. This check. These few are quite important. We need to verify them one by one. So first, we will do this. Okay, we can just attach it. Likewise, let's go below. We use his method called foundElement that returns a ptr and finds this life. Likewise, let's call this. Then we'll implement this code and explain it to everyone. Okay, actually, we don't need to use YouTube for this part. There's an error here. Let me see. There seems to be an extra parenthesis here. Yes, there's an extra parenthesis. So what should we do? It couldn't be found. So what's returned here is empty. In fact, its type is this kind. It's this type. It's an ape. This type will give 1. What it returns is this type. Let's take a look. Take a look. This doesn't look right. You can see that the element returned here. In fact, it returns a type like A-fu-chu star. Sorry, just now it should be it doesn't return an F1 star. It is the type of F1 star shi. Okay, let's take a closer look here. We can look at this. Oh, does it automatically infer this type? Yes, if the object inside is a pointer. If you look for it again, it will be this kind of emerging type. I think I messed up this part. Everyone can learn from this. Here, okay, we found it here. Okay, now move this over here. Let's take a look at the execution result. We can delete this comment, but since we need to set a breakpoint, let's not delete this comment for now. Okay, so let's move down from this point. It should be FindElement by return ptr. Let's see if there are any segment points. Yes, there are segment points. I think I just pointed at the segment. It should be okay. Look, this is empty. This is also normal. Okay, then I will demonstrate the thing I was trying to express just now. It's actually like this. This is what I mean. We will talk about a new actor, right? I see the spot. Actor. Note that it's an actor because it has a prefix. So actors. Then we can copy it. For example, this is good. We give it this again. We use ptr. Yes, we give it 3 elements. And these 2 are empty. Then when he actually goes to fun, you will find that this is very interesting. Look at its element type. Its element type is actually this type. This is the type I want to show you here. When comparing this, it might be difficult for us to compare. We use FindByKey. We should be able to use this. Yes, actually. It should look like this. Then we can't use Cju anymore. We always used Cju. Okay, so this proves that this way compiles without problems. This can also work. Take a look at of PD. This part has been renamed ER. Okay. Okay, actually, sometimes we write it like this. Write this actor like this. We will finish writing it. This actor free. Put it here. Then equals. Note that we are using equals here. We use equals. It's not. It's a draft. So it equals. It means if we have this object, then we take this object and reference it. Right? Then we can perform some operations here called cheese, cartar chou, quotient here. Here, if we need to pass something, we directly pass an FOE. Like this. Actually, we can also talk about this class separately, this way. Let's look at this function, whether it can be successfully called. Maybe we don't need this. Right, this is equivalent to us finding this object. If we find this object, we set its position to 0. So this thing is a bit convoluted. You need to understand it. So why did I get confused at the beginning? Actually, the meaning of this place is also the same. If our pointer exists, then we can... It points to this element inside the number. Then we perform a reference. We let it go to plus equals txt plus equals a txt. Modify. So let's take a look at what happens after these two things run. What does the effect look like? We need a reference point. Okay, we can see that. Let's take a look. The method we use is fine. So let's observe. Our current position is here. Let's start it now. Okay, there are no issues here. Okay, pay close attention to this. This pointer of his, he points to off. Let's see what happens after this finishes executing. What will it be? Let's take a look. A of modify, then add it on. So this is very fun, but this part is a little complicated. It's just that this spot has a core. Let's observe this result again. Let's execute it again. It went in. We can see that this actor has found it. This is the most relevant one in our scene. Then we can see its location here. We will simply jump out of this area. Let it execute completely. At this point, let's look at this actor. Do you see that its location is all zeros? Okay, this is what I wanted to show you. This is something that is frequently used in real-world practice. For instance, when we deal damage to an object, and whether or not the object has taken damage. If it has not taken damage, we will deal damage to it and modify its position. If it has already taken damage, then we now process it. Then we will look at this FindByPredicate. Then this is actually the same. I will just simply apply it like this. Right? Then we should just put it here. We won't write a separate function. We'll put it here. Here, let's try to find out if we can find one that equals 5. We can actually find it, right? Here, let's try to find out if it can equal 6. And then this 1, 2, 3, 4. This place is 7. It seems there isn't one equal to 6. We'll give it another one that equals 6. 1, 2, 3, 4, 5. Okay, let's execute and take a look now. Whether these two can be successfully found. Note that it also has this new O2 format. Okay, it means that actually many times, as for this O2 star, actually, it is mainly for this, so that the editor can see what type it is. And if we are also clear about it, then we can write it as O2. If you are not sure, I still recommend that at the beginning you explicitly state what type it is, even though sometimes writing this can be cumbersome and long, right? We found hello. We also found this 1, 2, 3, 4, 5, 6. No problem. Then at this spot, it has a filter, which means it will return a location group. It's actually equivalent to, as long as it meets this rule, it will filter out the element. Note that this is not an error. It's a filter. It means filtering. Let's take a look at it. So if we proceed now, we filter it so that what this means is comparing every element, if this element is not empty, and also take a string. Note that this is already a string, an element of the string. Its sort order is less than m. So As long as it's before M, it will filter it out. A, B, C, D, E, F, G. It might not have T, right? Let's take a look at its prototype. It is also a type of paradigm. Look, doesn't this look like it is actually a filter? You can see it well. A host of a certain type was spawned here. Then this place iterates through the elements inside. And this place is in work. In work is this particle. This particle is actually defined, the lambda function you wrote, and then execute it. If it's true, then add it. What's written here might be a little weird. When it's a for loop, it skips, it executes the next element. This is a more computation-based method. Let's look at more code. When you look at it next time, everyone will be very clear about what he's doing. We can just execute it now. Okay, let's put the previous part over there and we'll stay here. We just executed. Okay, let's see if the execution is finished now. It doesn't seem finished yet. We need to make it go one more line. Hey, he came in. Oh, there's an error here. Take a look. Perhaps it would be more appropriate to place it here. Let's see. There are 3 elements. Look, this HABCDEFGHIJKLMH is fine with the preceding proof. And regarding these two, perhaps its sorting is also before this M, before the M. So the 3 sides are equivalent to this TMMLMNOPQRST right? So this O is also further down. It should actually be. Okay, so let's stop here. For these few points, we have mostly covered the querying section for you. Its querying capability is very flexible. If we don't know these methods, we might get stuck in an infinite loop. But if you do know them, might use this index or particle method to do it. Can simplify the redundancy of our code. Thank you, everyone.